Let's start by understanding what a programming language is. Essentially, a programming language is a tool that allows humans to communicate instructions to a computer. Just like we use spoken languages to talk to each other, programmers use programming languages to write software that computers can understand and execute. These languages come in different types, such as low-level languages like machine code and assembly, which are closer to how computers actually operate, and high-level languages like Python, Java, or C++, which are more user-friendly and easier to read and maintain. Programming languages are used to build everything from operating systems and video games to web browsers and mobile apps. The choice of language often depends on the type of application being developed and the requirements of the project. Understanding the basics of programming languages sets the foundation for exploring different programming paradigms. Programming languages can be categorized into low-level and high-level languages. Low-level languages, such as machine and assembly languages, are machine-dependent and execute instructions directly on the hardware, making them fast but harder to understand and maintain. High-level languages, on the other hand, are designed to be more user-friendly, allowing programmers to write code that is easier to read, write, and maintain. Within high-level languages, there are procedural-oriented languages like C and Pascal, which focus on procedures and routines, and object-oriented languages like Java and Python, which organize code around objects and data. Every programming language has core elements such as input, output, loops, conditionals, variables, and data structures. These elements help programmers control the flow of a program and manage data efficiently. Understanding these elements is crucial for writing effective and maintainable code. Now let's dive into programming paradigms. A programming paradigm is a style or way of programming that provides a structure for organizing and solving problems. The two main categories are imperative and declarative paradigms. Imperative programming, including procedural and object-oriented programming, focuses on how a program operates, using statements that change a program's state. Procedural programming breaks down tasks into procedures or functions, while object-oriented programming organizes code around objects and their interactions. Declarative programming, on the other hand, focuses on what the program should accomplish without specifying how. This includes logic programming, functional programming, and database programming. Each paradigm has its strengths and is suited for different types of problems. For example, logic programming is great for expert systems, while object-oriented programming excels in building complex, reusable systems. Understanding these paradigms helps you choose the right approach for your project. In working with programming languages, following best practices is essential for writing clean, efficient, and maintainable code. This includes choosing the right paradigm for your project, keeping your code consistent and well-documented, and avoiding unnecessary complexity. Another important aspect is memory management. In languages like Java, memory is divided into stack and heap spaces. Stack memory is used for method execution and local variables, while heap memory stores objects accessible throughout the application. Understanding how memory is allocated and managed, including concepts like dynamic memory allocation and garbage collection, helps prevent issues like memory leaks and improve program performance. Additionally, using subroutines and methods can make your code more modular and easier to manage, but be mindful of overhead and complexity. By applying these best practices, you can write code that is not only functional but also robust and scalable. As technology advances, programming paradigms have evolved to include parallel and multi-paradigm approaches. Parallel computing involves dividing tasks among multiple processors to solve problems faster and more efficiently. This is especially useful for large-scale applications like data mining, real-time simulations, and scientific computing. Multi-paradigm languages such as Python and Java allow developers to combine different paradigms within a single project, leveraging the strengths of each. This flexibility leads to greater adaptability, productivity, and creativity. When choosing a paradigm or language, consider the nature of your project, the skills of your team, and the requirements of your application. By staying informed about modern programming approaches, you can create innovative solutions that are both effective and maintainable.